This is called the addition rule for counting. The ends you see there have to do with how many, the number of members, right, of elements. How many are in the union? How many are in set A? How many are in set B? How many are in both? This symbol, when you see this U, the union, it's like an or. So how many are in A or B or both? A or B or both. This means both. So you add everything, and then you remove, you subtract the repeats. Suppose we had 10 students who were meeting, and 5 were economic majors, 7 were accounting. How many are in both? So if you look at this formula, how many means you're counting. So this is like the one with the N. In both means you're looking for this. This is a both part. So if you let this 5 be the A and the 7 be the B, you replace the A and the B. How many are in this group? 5. How many are in the B group? 7. How many total students are there? 10. So you replace, make those substitutions, and you're going to isolate this. Simplify, you get a -2. Here's a negative. We still have a negative here. It came from the subtraction. But you could divide both sides by a -1, which tells us that in both groups, there were 2 students that were in both groups, both economic and accounting groups. Sometimes you're asked to work with 3 different groups. And in this type of problem, you always start from the middle. 9 are all in all 3 groups, whatever their groups are. The ones that are in all 3 groups belong here in the middle. Then you work yourself out. You take 2 circles at a time and find the intersection. Take these 2 circles at a time, find this intersection. So you're going to find these intersections next, and finally the outside. So notice you take 2 groups at a time. You take the BJ group, the BF group, the JF group. And then this part represents the total. One of these numbers will be given to you, which will be the intersection of the 3 circles. And you find this intersection, you find this intersection, and you find this intersection. From the list of information, fill in the intersections. Once you found these intersections, you move out to these other regions. And the way you find these other regions is that you take 1 circle at a time. In the information and list of information, they're going to give you what the whole circle equals. The B circle, the J circle, the F circle, whatever they happen to be. They'll tell you what they equal. So you take the B circle, for example, they tell you the total. Well, you just subtract these numbers and it'll give you this number. They give you the J circle. You add these 3 numbers, subtract it from the J number, and that gives you this region. Take this circle all by itself. They'll give you that number, and they just subtract 4, 9, and 2, for example, and they'll give you this region. And finally, the outside number, once you have all these numbers, what you do is they'll give you the size of the universe, subtract all these numbers, and it'll give you the outside number. This is the probability section, and these are some terms that we need to know for probability. Sample space, event, and experiment. A sample space is like your universe, all possible results, all possible outcomes. An event, when you're working with probability, is a subset of the possible outcomes. So an event is a subset of sample space. It's a portion of a universe, the event. Whatever event you're interested in, we'll see what those events can be. Then an experiment is the action that produces outcomes. For example, if you toss a pair of dice, well, that's the action that produces outcomes like, did it fall 1? Did it fall 2? Was it 1 and 1? The experiment involves the action that produces outcomes. Probability can only go from 0 to 1. The greatest probability is 1, or in percent form, it's 100%. The smallest probability is 0, or 0% in percent. all probabilities should fall within 0 and 1. We cannot go before 0. We can go above 1. Suppose E is the event, the happening. The event is the happening you're looking for. If you're betting on horses in a horse race, well, the event would be, what is it? What's the probability that horse number 1 will win? That's an event. Okay, probability has a formula. Notice it's a fraction. The E is the event, but notice this is a P because we're looking for the probability. But on this side, we have N's. So to find the probability, you have to count two things. How many members are in the event, and then how many members are on the sample space. The sample space is the same thing as the universe. So it's a fraction. How many fit the E description? How many total outcomes are there? You divide that, and that's your probability. Suppose you have a sample space for a toss die. So you toss a die, one die, these are the only things that you could get. You get a 1, a 2, a 3, a 4, a 5, or a 6, one die. So probability of even. So this is the universe. This is a sample space of tossing one die. Now, what's the probability of getting an even number? Well, how many are even? 1, 2, 3. So this would be replaced with a 3. How many total? Well, there's 1, 2, 3, 4, 5, 6 total outcomes possible. Divide those numbers, you always reduce, and you get a 1/2. Or you could put it as a decimal, as a 0.5, or as a percent, 50%.